Okay, so a trolley A moves along a horizontal surface at a constant velocity. So trolley A itself is moving at a constant velocity towards another trolley B, which moves at a lower constant speed in the same direction. So they are all going in the same direction, but the trolley B has a lower speed than trolley A. Table 3.1 shows the data for the trolleys. So this is basically giving us the initial speed for trolley B, the initial speed for trolley A. The two trolleys then collide elastically meaning that the total kinetic energy after collision is equal to the total kinetic energy before collision. And then they separate. Resistive forces are negligible. This is meant to tell you that the principle of conservation of momentum is obeyed, because it requires that there must be no external forces during the collision. Fig 3.2 shows the variation with the time t of the velocity v of trolley B. So this one is on my own writing. This was the actual graph according to the question. Fig 3.2 shows the variation in time t of the velocity v of the trolley. So if you check the velocity here, it's 0.12 until this point where it is 0.12. So it is obvious that the moment the velocity of trolley B, which is in front, which is collided into by the trolley A, which is behind, the moment the velocity increases from here to here, then it shows us that there is an increase in velocity. And if there is an increase in velocity, then that's the duration of the collision. So we come here now. The first question says, state what is represented by the area under a velocity time graph. It is basic knowledge that area under a velocity time graph gives us displacement, and the gradient of a velocity time graph gives us acceleration. Then next, use table 3.1 and fig 3.2 to determine the acceleration of the trolley during the collision. If you are trying to find acceleration, there are two ways in physics. Acceleration is either final velocity minus initial velocity over time, or we find acceleration by knowing the resultant force. The resultant force is equal to mass times acceleration. Now, we don't have any force mentioned in that question, so we cannot be using the issue of resultant force. We can only be using the issue of acceleration equals to final velocity over minus initial velocity over time taken. So during the collision of trolley B, so we come here for trolley B. The collision starts from here, which is 0.15 seconds to 0.35 seconds. So it takes 0.2 seconds. And the initial velocity during the start of the collision is 0.12. The final velocity is 0.3. So using that data, we can find our information. Final velocity minus initial velocity, final velocity, initial velocity, final time minus initial time to find the time taken. This gives us 0.9 meters per second squared. So that there is our acceleration of B during the collision. Then you're supposed again to use the table 3.1 and table 3.2 to determine the magnitude and direction of the final velocity of trolley A. The magnitude and direction of the final velocity of trolley A. So considering these two trolleys, trolley A, trolley B, they were moving like this. Then after collision, we can expect that trolley B, it's only common sense that it will continue moving in the same direction, because it was barged into from the behind. So there's no way that it can change direction. So that's trolley B. Besides, the graph actually shows us, it's a velocity time graph, shows us that the velocity is positive here as 0.3 after collision. So anyway, it is continuing in the same direction as the direction to the right has been chosen to the positive direction already. Then we don't know now for A. Finally, we don't know where the velocity is going, but we can assume that it's going in this direction. So I'll put x here as its velocity, and then or maybe let me just put and use v as its velocity. final velocity. This one we know that the final velocity of this one is 0.3, initial is 0.12. Let's check for A. The initial velocity for A is 0.48. Is 0.48. So 0.48. So now we are going to use the principle of conservation of momentum, because we know that there was no external forces as it was said by the question. So the magnitude and the direction of the final velocity of trolley A can be found by using the principle of conservation of momentum, which says total momentum before collision equals to the total momentum after collision, provided there are no external forces. So momentum of the masses are given also here. The mass of A is 0.25 and the mass of B is 0.75. Knowing the masses is important, because then we can say total momentum of A, the momentum of A before collision is its mass of 0.25 multiplied by its velocity of 0.48, like that. Then plus the momentum of B, which is its mass of 0.75 multiplied by its velocity of 0.12. Then we go to the other side. After collision, the mass of A is 0.25, remember, and the velocity is V, which we don't know. Then for B, the mass is 0.75 again, and the velocity is 0.3. That's what happens here. So simplifying this, multiplying this part gives us 0.12, multiplying this part gives us 0.09, multiplying this part gives us 0.025, and taking this to the other side gives us minus 0.015, which is equals to 0.25 V. Then we divide both sides by minus 0.015. We get a velocity of minus 0.0160. Now I didn't need to write this part here because it's just the magnitude which was needed here. But the negative tells us that the direction of the velocity of the trolley A will be to the left, since positive has been chosen as to be to the right. Then finally, on sketch 3.2, sketch the variation on figure 3.2, sketch the variation of the velocity of trolley A with the time from t is equal to 0 to t is equal to 0.50. So we now know the original velocity of trolley what is it? Trolley A, it's 0.48. That's why we come here and we draw 0.48 here, and it is constant, that velocity, as we were told by the question here. We were told that it's constant, it's moving at the constant velocity towards trolley B. So it is only changing when collision starts, and collision started at this particular point. That's when collision started. So that's when the velocity starts to change. Otherwise, it was constant at 0.48 as we were told. Then also we know that the final velocity is 0.0 minus 0.06. So that's what we do here. Minus 0.06 is here. That's why it's a constant velocity after the collision is finished. So again, it ends when the collision is finished, like that. So what was left was just joining this remaining part here.